Connecting the rectangular survey system to your prior learning. In the previous section, you learned that every legal description must precisely identify a parcel of land, so surveyors, courts, and real estate professionals can agree on exactly which property is being discussed. Metes and bounds can describe irregular shapes, and recorded plats organize subdivision lots. But the rectangular survey system gives the nation a consistent, predictable grid that covers enormous areas of land. Arizona, in particular, relies heavily on the rectangular survey system because much of the state was originally federal land surveyed before being conveyed to private ownership. Whether you are selling a raw 5-acre parcel outside Snowflake, a ranch tract in Cochise County, or a newly platted subdivision lot in Gilbert, the rectangular survey system appears in deeds, title reports, environmental disclosures, and many documents that establish land boundaries. Understanding this system is foundational to working in Arizona real estate. Purpose and origins of the rectangular survey system. The federal government created the rectangular survey system, also known as the Public Land Survey System, to replace long and varied metes and bounds descriptions that made large-scale land transfers too slow and inconsistent. As the United States expanded westward, millions of acres needed to be surveyed and conveyed, and a simple, uniform system was necessary. Instead of describing land by creeks, cottonwoods, wagon trails, or old stone mounds, the rectangular system relied on mathematical precision, dividing land into townships and sections. In Arizona, this process began in the mid-1800s and continued into the early 20th century, shaping the layout of counties such as Maricopa, Pinal, Yuma, and La Paz. Many of the rural parcels sold today in Arizona are still described by their fractional location within a township and section, making the rectangular system a daily tool in Arizona real estate practice. Principal meridians and baselines in Arizona. The rectangular survey system begins with imaginary reference lines. North-south lines are called meridians, and east-west lines are called baselines. Every surveyed region has one principal meridian and one baseline that serve as the origin of its grid. Arizona is unique because it contains two major principal meridians, the Gila and Salt River. Principal meridian is located near Phoenix and controls surveys in the central and southern portions of the state, including Maricopa, Pinal, and Pima counties. The Arizona Principal Meridian, established near the Navajo Nation, governs surveys in much of northeastern Arizona, including Apache and Navajo counties. When you see a legal description, such as Township 3 North, Range 5 east of the Gila and Salt River Meridian, you are seeing the rectangular system anchoring that parcel to Arizona's surveying history. Ranges and tiers. From the principal meridian, surveyors measured 6-mile-wide vertical strips of land, called ranges. These strips run north and south, and are identified by their position relative to the meridian. For example, a parcel located east of Phoenix might indicate that it is in Range 6, east of the Gila and Salt River Meridian. West of Phoenix, properties in Buckeye or Tonopah may be located in ranges identified as Range 2 West or Range 3 West. From the baseline, surveyors measured 6-mile-wide horizontal strips called tiers or township strips. These strips run east and west and are identified as Township 1 North, Township 2 South, and so on. Much of Maricopa County falls in the first few tiers north and south of the baseline, which is why you often see legal descriptions such as Township 1 South or Township 3 North in property deeds and subdivision reports. Townships and Arizona examples. Where a specific range and a specific tier intersect, they form a square known as a township. Because meridians and parallels are spaced 6 miles apart, the township is 6 miles by 6 miles, and therefore contains 36 square miles. Arizona's townships cover vast regions of ranchland, desert, and mountain terrain. For example, a 40-acre parcel outside Casa Grande may be located in Township 6 South, Range 6 East, while a remote cabin lot near Show Low might appear in Township 10 North, Range 21 East. Even suburban homes in Chandler, Mesa, or Gilbert sit inside one of these townships, though the subdivision legal description usually hides the township behind lot and block references. Understanding townships helps you grasp the big picture of Arizona's land layout, township identification, and real-world illustration. The township designation always combines the tier, range, and principal meridian. A legal description might read Township 4 North, Range 3 East, Gila, and Salt River Meridian. This means the parcel lies 4 tiers north of the baseline and 3 ranges east of the principal meridian. If a title report adds that the parcel lies in Section 24, you now know it is the 24th 1-mile square within that specific township. This is often how rural parcels in Cochise County, Mojave County, or Yavapai County are identified. For example, a ranch listing might state that the property includes the south half of Section 9, Township 17 North, Range 3 West. With just that description, a surveyor can locate the land anywhere in Arizona. Township and range grid. Students match each letter to the correct definition below. A. Township B. Range C. Principal meridian D. Baseline E. Sections within a township F. Fractional subsections match the letters. A. 6-mile by 6-mile square B. Vertical 6-mile wide strip running north-south C. North-south reference line for measuring ranges. D. East-west reference line for measuring townships. E. The 36 1-mile squares inside a township. F. Halves, quarters, and quarters used to describe acreage. Correct matches. A equals township. B equals range. C equals principal meridian. D equals baseline. E equals sections. F equals fractional subsections. Arizona township example. Students match each label to the correct township component. 1, T3N2, R7E3, Gila, and Salt River Meridian 4, Section 12.5, NW 1/4 of Section 12. Match the labels. Township designation, north or south of the baseline range. Designation east or west of the principal meridian identifies the principal meridian used for all measurements. One of the 36 1-mile squares inside the township fraction of the section used to describe specific acreage. Correct matches. 1 equals township, T3N. 2 equals range, R7E. 3 equals principal meridian, Sheila, and Salt River Meridian. 4 equals Section 12.5 equals NW, 1/4 of Section 12. Corrections for the Earth's curvature. The rectangular grid appears perfectly uniform in theory, but Arizona's vast landforms reveal a practical challenge. The Earth is curved. Meridians converge as they move north or south, meaning that mathematically perfect squares cannot always be achieved across large distances. To solve this, the rectangular system incorporates correction lines and guide meridians. These additional reference lines help surveyors prevent accumulating errors. In Arizona, these correction lines explain why some sections near the tops of townships are irregularly shaped. A buyer purchasing property near a correction line in northern Arizona may find that the northern edge of the section is slightly larger or smaller than exactly 1 mile. These variations are normal and recognized under Arizona law, and they show why accuracy in legal descriptions is so important. Sections and Arizona section patterns. Each township is divided into 36 sections, arranged in a serpentine numbering pattern beginning in the northeast corner. Section 1 is the top right of the township. Section 6 is the top left. Section 7 is immediately below Section 6, and the pattern continues until Section 36 in the southeast corner. Many Arizona land sales still use section references because much of the state is rural. For example, a listing near Wickenburg might identify a property as the northeast quarter of Section 22, Township 7 North, Range 5 West. A farm outside Yuma may locate itself in the east half of Section 10, Township 9 South, Range 23 West. Navajo County and Apache County frequently use section references for ranch land east of Holbrook and St. John's. By knowing the pattern, you can visualize exactly where the parcel sits within the larger grid. Township section layout. Students match the pattern to the correct description. Pattern row 1, 1, 2, 3, 4, 5, 6. Row 2, 12, 11, 10, 9, 8, 7. Row 3, 13, 14, 15, 16, 17, 18. Row 4, 24, 23, 22, 21, 20. Row 5, 25, 26, 27, 28, 29, 30. Row 6, 36, 35, 34, 33, 32, 31. Match the descriptions. A. Begins in the northeast corner. B. Moves east to west across the first row. C. Snakes back west to east on the second row. D. Continues alternating until reaching the southeast corner. E. Contains 36 sections total. Correct matches. A equals row 1. Section 1B equals row 1, 1 to 6. C equals row 2, 12 to 7. D equals all alternating rows. E equals whole diagram. Understanding fractions of a section. Because each section contains 640 acres, any fractional piece of a section can be measured by calculating that same fraction of 640. Arizona uses these fractional descriptions extensively in agricultural and ranching contexts. The north half of a section equals 320 acres. The southwest quarter equals 160 acres. The east half of the southwest quarter equals 80 acres. A typical Arizona rural parcel offered for sale along Highway 260 might be described as the southeast quarter of the southeast quarter, which equals 40 acres. In Navajo County, land investors often buy 20-acre tracts described as the east half of the northeast quarter of the northwest quarter. That combination equals 1/2 times 1/4 times 1/4, or 1/32 of a section, which is 20 acres. Understanding these fractions allows a real estate professional to speak confidently with buyers interested in raw land. Fractions: 1 quarter, 1/4, 2 half of a quarter, 1/2 of 1/4, 3 quarter quarter, 1/4 of 1/4, 4 quarter quarter quarter, 1/4 of 1/4 of 1/4. Match each fraction to its acreage. A. 40 acres. B. 80 acres. C. 160 acres. D. 10 acres. Correct. Matches: 1 equals 160 acres, 2 equals 80 acres, 3 equals 40 acres, 4 equals 10 acres. Arizona-based fraction examples. To illustrate further, consider a parcel near Prescott, described as the north half of the northwest quarter of Section 14. This equals 1/2 times 1/4 of a section, or 1/8, which is 80 acres. Another property in Pinal County might be described as the southwest quarter of the southwest quarter, which is 1/4 times 1/4, or 1/16 of a section containing 40 acres. A mining claim near Globe might include the west half of the northeast quarter of the southeast quarter, which is 1/2 times 1/4 times 1/4, or 1/32 of a section, containing 20 acres. These fractional patterns appear constantly in Arizona land sales disclosures, easements, agricultural leases, and water rights documentation. Example legal description. The SC 1/4 of the NW 1/4 of Section 10, Township 4 North, Range 5 East, Gila and Salt River Meridian match. Each component 1. SC 1/4 of NW 1/4 2, Section 10-3, Township 4, North 4, Range 5, East 5. Gila and Salt River Meridian descriptions. A. Identifies the principal survey line used in Arizona. B. Specifies the 6-mile square in which the parcel lies. C. Identifies the fractional section, 40 acres. D. Indicates distance north of the baseline. E. Indicates distance east of the principal meridian. Correct matches: 1 equals C, 2 equals B, 3 equals D, 4 equals E, 5 equals A. Quick method for converting fractions to acres. When you need to calculate acreage quickly, multiply the denominators of each fraction and divide 640 by the product. This method is especially useful in Arizona agricultural areas, where parcels often consist of multiple small fractional pieces. For example, a parcel in Gila County, described as the east half of the west half of the southwest quarter, involves denominators of 2, 2, and 4. Multiplying 2 times 2 times 4 gives 16. Dividing 640 by 16 yields 40 acres. In Cochise County, if a buyer wants to know the size of the northwest quarter of the northeast quarter of the northwest quarter, multiply 4 times 4 to get 64. Dividing 640 by 64 yields 10 acres. This quick method helps you answer acreage questions without needing a calculator. Rectangular survey system and Arizona subdivision practice. Arizona subdivision developers often begin with a full section or multiple sections and then create lot and block subdivisions within the grid. For example, a developer in Gilbert may design a new subdivision that occupies the east half of Section 18. Within that area, the subdivision plat will divide the land into lots, blocks, and tracts. The recorded plat will identify each lot by number and block, but the full legal description still includes the underlying section and township location, such as Lot 4, Block 7 of White Wing Estates, being a portion of the east half of Section 18, Township 2 South, Range 7 east of the Gila and Salt River Meridian. Even though homebuyers rarely see the section details, the rectangular system remains embedded in every Arizona subdivision. Describing elevation in Arizona. Arizona's diverse landscape includes mountain regions, canyons, mines, and multi-story condominium towers, requiring clear elevation descriptions. Surveyors rely on datums and benchmarks to determine vertical position. The original United States Geological Survey datum measured from mean sea level, but in practice, Arizona surveyors often reference local benchmarks. A benchmark may be a brass cap cemented into a sidewalk in Phoenix with a recorded elevation. That benchmark then serves as the reference for measuring the elevation of a second-floor condominium in downtown Phoenix, or the depth of an underground utility tunnel in Tucson. In Flagstaff, benchmarks help determine proper drainage for hillside homes. In mining regions near Globe and Miami, elevation descriptions define subsurface mineral rights, specifying how far below a datum the rights extend. Concepts 1, Datum 2, Benchmark 3, Elevation, Measurement 4, Air Rights 5, Subsurface Rights. Match the definitions. A. Vertical reference point used for measuring height or depth. B. A local permanent marker used as an elevation reference. C. Measurement above or below a set datum. D. Property rights above the surface, used in condos or towers. E. Property rights below the surface, used in mining and utilities. Correct matches: 1 equals A2, equals B, 3 equals C4, equals D, 5 equals E. Basic measurements, used in Arizona land descriptions. Arizona real estate practice relies on standard units of linear and area measurement. 1 mile contains 5,280 feet. 1 acre contains 43,560 square feet. A full section contains 640 acres. A township contains 36 square miles. Many Arizona agricultural leases refer to quarter sections and half sections. Land planners often describe parcels by their section alignment, such as 660 feet by 1,320 feet for a 20-acre tract. In the metric system, used occasionally in engineering work, 1 meter is 3.28 feet, and 1 kilometer equals 1,000 meters. These units affect practical matters, from calculating well setbacks in rural counties to determining the width of road easements in new subdivisions. Arizona examples. Pulling it all together, imagine a buyer asks about a 40-acre parcel for sale outside Snowflake, described as the southeast quarter of the northwest quarter of Section 4, Township 12 North. Range 22, east of the Arizona Principal Meridian. You can explain that Township 12 North places the property 12 tiers above the baseline, and that Range 22 East places it to 22 ranges east of the Principal Meridian. Section 4 is located near the northern part of the township. The southeast quarter of the northwest quarter equals 1/4 times 1/4 of 640 acres, giving 40 acres. If the buyer wants an additional parcel, described as the northeast quarter of the northwest quarter, that also contains 40 acres. Together, they form an 80-acre block, which many Arizona ranch buyers seek for grazing purposes. Now, consider a new subdivision in Queen Creek located in a portion of Section 32. The plat divides the east half of the southeast quarter into 250 lots. Although each lot is roughly 1/4 acre, the legal descriptions still reference the township, range, and section. A title commitment might state that Lot 87, Desert Bloom Estates, is located within Section 32. Township 2 South, Range 7 East, Gila, and Salt River Meridian. This shows how modern Arizona communities remain tied to the 19th century rectangular survey system. Review summary. In this expanded section, you learn that the rectangular survey system forms the backbone of Arizona land descriptions. The system begins with principal meridians and baselines that create 6-mile-wide ranges and tiers. Where a range and tier intersect, they form a township measuring 6 miles on each side and containing 36 square miles. Townships are divided into 36 sections, each 1 mile by 1 mile, containing 640 acres. These sections follow a serpentine numbering pattern from 1 to 36. Arizona relies heavily on these township and section divisions for ranch land, agricultural leases, land sales, and even subdivision creation. You saw how fractional parts of sections, such as halves, quarters, and quarters, create parcels of different sizes, commonly seen in Arizona's rural counties. You learned how to calculate acreage by multiplying denominators and dividing 640 by the result. You examined examples from Maricopa, Pinal, Apache, Navajo, and Yavapai counties, showing how the system defines parcels ranging from small residential lots to large ranch tracts. You also explored how recorded plats fit within the rectangular framework and how elevation descriptions using datums and benchmarks help define air rights and subsurface rights in Arizona's varied terrain. Together, these concepts form a foundation for reading deeds, understanding title reports, evaluating land listings, and communicating effectively with clients who seek to understand the size and location of Arizona property. Discussion. How does understanding Arizona's principal meridians help you answer client questions about rural properties? Suggested answer. When clients look at rural parcels in areas like Apache County, Pinal County, or Yuma County, their legal descriptions almost always reference a principal meridian. Knowing whether the land falls under the Gila and Salt River Meridian or the Arizona Meridian helps you understand where the township is located and how to interpret the legal description. This allows you to explain the property's location confidently and guide clients through title searches, mapping tools, or county records. A buyer is considering purchasing 2 adjoining 20-acre parcels described as the east half of the northeast quarter of the northwest quarter and the west half of the northeast quarter of the northwest quarter. How would you explain the relationship between these parcels? Suggested answer. Both parcels lie within the northeast quarter of the northwest quarter, which is already a 40-acre quarter-quarter division. The east half and west half each represent 1/2 of that 40-acre area, meaning each parcel contains 20 acres. Together, they form the full northeast quarter of the northwest quarter, giving the buyer a consolidated 40-acre block. Explaining the relationship this way helps the buyer visualize how fractional descriptions connect to one another. Why is it important in Arizona to understand that subdivisions often reference the rectangular survey system even when the everyday legal description uses lot and block. Suggested answer. Arizona subdivisions frequently sit within specific sections and townships, even though lot and block descriptions are simpler for consumers. Understanding both layers allows you to read full legal descriptions in deeds, title commitments, and public reports. It also helps when researching easements, flood zones, or land use restrictions that are tied to section lines. Knowledge of the rectangular system ensures accuracy when representing a property's true legal boundaries. Closing remarks. The rectangular survey system is more than a grid of lines on a map. It is the underlying structure that gives meaning and order to Arizona land ownership. Every ranch, desert parcel, suburban subdivision, and condominium tower exists somewhere within a township and section laid out generations ago by surveyors working under federal law. By mastering this system, you gain the ability to interpret legal descriptions, calculate acreage, explain parcel relationships, and understand how Arizona's land is organized. This knowledge strengthens your ability to serve your clients, whether they seek 5 acres outside Snowflake, a 40-acre ranch near Prescott, or a lot in a new subdivision in Gilbert. As you continue your study of real estate, the rectangular survey system will connect naturally to zoning, development regulation, subdivision law, and environmental considerations that shape how Arizona land is used and transferred.